Hello guys, so we have already talked about the midpoint theorem in our previous video. Now in this video we are going to talk about the converse of midpoint theorem. Converse of midpoint theorem states a line drawn through the midpoint of one side of a triangle parallel to another bisects the third side. Now again we are going to draw the diagram first as A, B, C, D and E. Okay, so here we have to write down the first step of proving, right, what is given to us. That a straight line is drawn through the midpoint of one side. So let's take that D is the midpoint of AB. Okay, and we are definitely given a triangle, so of triangle ABC, and we have drawn DE parallel to BC. Prove now. That's the second step. We have to prove bisects the third side, right? So DE bisects AC. That is my third side. So therefore we can say that I have to prove AE is equal to EC. So we can't prove it, we have to do some construction, guys. So for construction we will draw CF, which will be parallel to BA, as we did in midpoint theorem, right? And this will meet the DE produced line at F. So we have made this construction. Let's write down, draw CF parallel to BA. This we had done in our proving midpoint theorem also. So this meets, so which meets DE produced at F. Okay guys, so let's understand through this diagram. I have marked everything, and let's see. So we know that BCFD is a parallelogram because both pair of opposite sides are parallel to each other. So we can say it is a parallelogram, and you can see my video on how you can call a quadrilateral a parallelogram. I have added in the description box. So as this is a parallelogram, I can say that DF is parallel to BC, right? Because opposite sides of parallelogram are equal and DB is equal to CF. Now as we know AD is equal to DB, so my AD will also be equal to CF, correct? Now I am taking the triangles ADE and FCE. So now in this case I can see that angle DAE is equal to angle FCE because they are alternate angles, as AD is parallel to CF, correct? As this is parallel to BD, so obviously this is also parallel to that. Now we have angle ADE is equal to angle CFE. They also form the alternate angles, and we already know that AD is equal to CF. We have proved it. So these two triangles are congruent by ASA property. So I can say that AE is equal to EC by CPCT, or the corresponding parts of congruent triangles are equal. So we have to prove it like that. Now let's write down our proof. So we have to write down a few statements and we have to write the reasons for those statements. Okay, so first statement I can say is that BCFD is a parallelogram. Correct? Why we have the reason DF is parallel to BC and CF is parallel to BD. One was given, DF was parallel to BC was given, and CF parallel to BD we did by construction. Okay, now so that we can say that my BD is equal to CF, right? Opposite sides of parallelogram. BD is equal to CF, then this is also given that BD is equal to DA, as D is the midpoint of AB, and this is given to us. So D is midpoint, so BD is equal to. So now I can compare that from my second and third point. I have AD or DA is equal to CF. So this we can say from point 2 and point 3, right? So this is equal to this because both are equal to BD. Correct? So this is fine till here. Now we'll take the triangles. So now in triangles ADE and triangle CFE. Okay, so in these triangles I can say that AD is equal to CF. We have set it in our fourth point, and second point angle DAE is equal to angle ECF. DA is equal to ECF. They form alternate angles as those two sides are parallel. Now we have the third point, angle ADE is equal to angle EFC. These also form alternate angles. Correct? So now my triangles are congruent, guys. So therefore triangle ADE is congruent to triangle CFE. Triangle CFE. Okay, why? What property? ASA, property of congruence of triangles. Okay, so now therefore I can say that AE is equal to EC, as CPCT or the corresponding parts of congruent triangles. Correct? So we have proved that AE is equal to EC. That's what we were supposed to prove. So we had proved the midpoint theorem in our previous video, and we have proved the converse of midpoint theorem in this video now. So wait for new videos and see you guys there. Stay tuned.